Hello, everybody.
I thought we changed our intro.
Hey, what's up?
Whoa, Miss Newsom's here!
She just appeared.
Out of nowhere. I mean, it was like a snap, Miss Newsom's here.
Eating
And
her
now
Cheetos.
So today we're talking about proportional relationships, which are a direct variation, and non-proportional relationships.
Direct variation.
That's a new word. It's a fancy word for something that varies proportionally.
I feel so mature.
Me too.
Let's go.
Wow, that's weird.
Let's move on.
Okay. We will solve problems by using direct variation / proportional relationships and non-proportional relationships. That's your learning target. Write it down. Hint, hint. Yes.
You should already know by this point.
You should know the fancy fun thing we're doing. So write that down in your journal. Direct variation equations can be written in the form of y equals kx.
OMG, doesn't that look
so familiar because it's a proportional relationship. Cool.
Yeah,
The k is your
constant of proportionality, but in this case, it's our constant of variation. So it's
constant variation, constant proportionality. What else is it?
Slope.
Slope.
Rate of change.
Rate of change. I mean, it's got so many names. It's not even funny. And I know a lot of you are like, but that's a K and that's a C. Where did they get it?
Yeah,
just so you know.
At least it's like k.
Well, no.
I said. K constant.
The reason is because in English, the k sound can be a K or a C. In other languages, it's usually just a K. They do other things. And so the K comes from another language that the k sound comes from a K. And so I don't even know what language it comes from. Make sure you do have that written down. I'm sorry, I flipped that a little early. If you don't have it written down, write it down. Miss Green is actually looking it up for some reason.
I want to see if somebody tells me somewhere.
Did you look up where the origin?
Well, I'm at Wikipedia. Isn't everything on Wikipedia true?
No, everything is not true on Wikipedia. Anyways, so I am driving from Fort Worth to Edinburgh. I'm sorry, I had a cousin who went to Edinburgh. I'm driving from Fort Worth to Edinburgh. I drive 600 miles in 8 hours. How many hours would it take me to drive 825 miles? Why did you put this one on the bottom?
Too long.
Before we go over that word problem, I want to talk about this for a minute.
Oh, I'm sorry.
X is your independent variable and Y is your dependent variable. Your X affects your Y. So when I'm looking at this, my X kind of just lives on its own. Whatever happens to X is going to affect what happens to Y. So if I'm like talking...
Whatever you input will affect what you get on your output.
So however many hours I work will tell me how much money I make.
How much studying I do will tell me my grade. I mean...
Correlate, yeah.
It's a direct correlation of two. If I study an hour, I could make 100. Or if I study 3 hours, things like that. If I work 5 hours, I make $20.
If I buy 20 pizzas, I will have
less money.
Pizzas. I will have a lot of slices.
A lot of slices.
So X, your independent variable, and your Y. X is your independent variable. Y is your dependent. X affects Y. Now let's look at that problem again. I'm driving from Fort Worth to Edinburgh. I drive 600 miles in 8 hours. How many miles would it take me to drive 825 miles? So my X, my independent, is actually how many hours I drive. Because the number of, what?
I can't find it.
Oh.
You know what? If you can find YK is a K, I will give you
For constant.
5 badger bucks, which is 25.
What if I find it?
Yeah.
What if you find it?
Yeah,
I'll give you a big hug.
Anyways, our hours is actually our independent variable because we can drive a certain number of hours. That's going to tell us how many miles we've been. If we're driving miles per hour,
However many
miles per hour depends on how many hours you're driving. How many miles you drive depends
How many
on
hours you drive depends on how many miles you go.
Did we say that right?
Yep. This is your independent variable.
This one's your
however
independent.
many hours you drive will
depend on your miles will depend on your hours.
Your miles will depend on your hours.
We're saying it funky, and that's what's getting me.
You're saying it right, but you're pointing at the wrong thing.
Yes.
Okay.
Your miles depend on your hours. So hours is our X, and miles is our Y. Now, it doesn't tell us how many miles per hour we're driving, does it? So does it give us our constant of proportionality?
No.
No. We need to figure that out. So if we have Y... Wow, my pen is dying. Can I have a new pen?
You drove too many miles.
Thank you. I did. It drove too many miles. Y equals KX. I'll fix it later. I know. It's full.
It's full.
It just takes some scribbling, and I just don't feel like doing that right now. So Y equals KX, and we know K is hours, Y is X is hours, Y is miles. I cannot talk today. Oh
Maybe
my gosh.
label it. Can we label it? We labeled
we
it
did
here,
label it here.
And you're still doing it wrong.
I know. I told you I can't talk today. So I'm going to just plug in the information I have into the X and Y, and then I'm going to find my K.
Okay.
So I've got Y, my miles, was 600 miles. So 600 equals K times 8. We're looking for K.
Oh, solving equations.
Solving equations.
It's a one-step
Yay!
equation.
Oh my gosh,
All I
that's
have to
great.
divide by 8. Divide by 8. What is
Oh,
600
look,
divided by
miles
8?
per hour.
Ha,
Look at that.
Look at that.
Y over
X.
Proportional relationship.
Yes. What is 600 divided by 8? If I can't talk, do you
75.
think I can do it? Okay, 75 equals K. She already did this already.
I already did it on the
So now I've got Y equals KX. And my question I'm sorry, Y equals 75X. Wow, what is going on with me today?
a lot.
I know a lot is. So now I want to know how long will it take me to drive 825 miles? So miles goes into Y, 825 equals 75X. Do we have another
there we go.
one-step equation?
Yes, divide.
Divide by 75. Divide by 75. And 825 divided by 75 is?
If I'm not mistaken, it's 11.
8. Okay.
11?
11.
So 11 equals X. So it's going to take me 11 hours to drive 875 miles. Is this a proportional relationship using direct variation? Or is this a non-proportional relationship?
It's proportional
Because we used Y equals KX?
because we used Y equals to KX, which is the same thing as direct variation.
Right.
Yes.
And at 0 hours, I mean, he's going
At
to be
0
going
hours,
0
he
miles.
hasn't gone anywhere.
So 0, yeah.
Yeah. So that is our direct variation. It's kind of talking proportional versus non-proportional. What makes it non-proportional? Why is there a
Thank
Cheeto
you.
in my video?
Thank you for the Cheeto. Cheeto.
Oh, please enjoy yourself. Everybody have
What makes this non-proportional? If we were to have a non-proportional relationship, what would make it non-proportional?
Plus B.
Plus B, a y-intercept. If it was not going through the...
origin.
Yay! Okay, simple, right? Non-proportional goes through... Does not go through the origin. Does not go through origin.
Proportional does not go through the origin, yes.
Because
Origin.
non-proportional will look like this.
Proportional goes through origin.
Remember,
Origin.
Y
And it's a
equals to MX plus B.
And y equals kx. That's it.
They're both linear.
They're both
That's like
linear.
I say, they're both going to
They're both
a straight
linear
line.
functions. They
Except
are all
this one
functions.
goes through its own Y. It doesn't necessarily
Go through the zero.
This one must go through the zero.
So I hear them coming back
Bell's
from
gonna ring.
lunch.
Gotta go. Love you. Bye.
Bye.